Hello everyone. A converging lens is used to form an image on a screen. When the upper half of the lens is covered by an opaque screen, half the image will disappear, complete image will disappear, intensity of image will decrease, and intensity of image will increase. To answer this question better, we need to see how a converging lens works. This is the ray diagram of a converging lens. The rays emerge from the object and then after passing through lens they converge on a screen. Now we'll draw the diagram of what happens when we cover half of the lens. As we know that light emerges in every direction from this point. Therefore, light will also go from here to the middle of the lens and then form the complete image. But since the half of the lens is covered, the intensity of the light reaching the screen will decrease. Therefore, the image formed will have a decreased intensity. Thank you.
Hello students, our question is consider a concave mirror and convex lens and refractive index of convex lens we have given of focal length 10 cm each separated by a distance of 50 cm in air. Refractive index of air is 1 as we already know it. An object is placed at a distance of 15 cm from the mirror. Its erect image formed by this combination has a magnification m1 when this setup is kept in the medium of refractive index 7/6. So after this whole setup is being placed in the refractive index of medium 7/6, the magnification becomes m2, the magnitude of m2 by m1. We have to find this. So first we form the image formation. So the image will be first formed by concave mirror. Okay, so our first step will be image by concave mirror, and we are taking the direction of light as positive for the mirror. So this is our positive and this is negative. We can change conventions also, but we will still get the same answer. So we know the formula. So 1 by v plus 1 by u is equal to 1 by f, where f represent focal length of what? Mirror. Okay, so 1 by v and it will be 1 by f minus 1 by u. Now we put the values with conventions. So our focal length will also be in the negative side, and it is how much given in to us? It is 10. So we put the values. So 1 by v will be how much? Our focal length is minus 10 minus of minus 15. So we get here 1 by v will be equal to how much? It will be 1 by 15 minus 1 by 10. So it will be, our v will be, if we solve this, it will be 30 or minus 30 centimeter. Now this will act as an object for our convex lens. So we do our second thing, image formation. By convex lens. Okay, now we write the formula. It is 1 by v minus 1 by u is equal to 1 by f. Now our u and f are given. U will be the image in the first part. So first we find the distance of the object from the convex lens. So this whole distance is 50 and image is forming at a distance of 30 from here. So our this distance will be 30. From here to here it will be 30. So it will be 50 minus 30, which is simply 20, and it will be minus of 20. So our u will be minus of 20 centimeter, and focal length for our convex lens will be positive, so it will be f, and it will be 10 centimeter. And our 1 by v will be how much? It will be f plus 1 by u. So if we put these values in the formula, so our 1 by v will be how much? It will be 10 and minus of 1 by 20. So our v will be, we can easily say that will be simply 20. So our v is 20 centimeters, but it is positive. And now we find the magnification for both the parts. So magnification here will be m1, and it will be minus of minus v by u. Our v is how much? It is minus 30, and u is what? Minus of 15. So it will be minus 2. This is our m1, and m2 will be how much? It will be v by u. So because it is the case of length, so it will be plus v by u. And if we do this, our m2 will be, our v is how much? 20 centimeters, which is in positive, and u is in minus 20. Now m2 will be minus 1. If we find the combined magnification of both or whole system or both lenses or both systems, we can say, so it will be total magnification will be equal to m1 into m2, which is minus 1 into minus 2, which is 2. So this is 2, and this is the value of our m1, which is given, which is termed as m1 in the question. So this is our one thing. Now the whole system is placed in water. So it is our B part, and system is placed in water. Sorry, not in water, in some liquid with refractive index 7 by 6. It will be in liquid with refractive index and 7 by 6. Now what we do here, we use lens making formula. So our f for first lens, we can find it. So f in air, I am writing it. So it will be n2 by n1 minus 1, and it will be 1 by r1 minus 1 by r2. We don't know the value of r1 and r2, and we have nothing to do with them. So f air will be how much? N2 will be the refractive index of glass, which is 1.5, and n1 will be the refractive index of medium, which is 1. So it will be how much? It will be 1.5 minus 1, and our r1 and r2 will remain as it is. Why we are taking them into account, I will tell you, but you will know already. But first we have to write F for liquid, because we have changed the medium. So our n1 will change to 7 by 6 now. So if we write, so it will be 1.5, it will be 7 by 6 minus 1, and our r1 and r2 will remain as it is. Now we have to find basically F liquid, okay, and we know F air, so we take their ratio. So our F air and F liquid will be how much? They will be 0.5 divided by 1.5 into 6 divided by 7 minus 1. Okay, And if we calculate F liquid from here, so F liquid will approximately be equal to 70 by 4. We know F air. F air is what? It is 10 centimeters. If you put the value of it, its value will be 70 by 4 centimeter. Now we have to calculate the image again, or the position of image again. So we will use U, and U will be minus 20 as that of before. So our 1 by V, the formula will be 1 by V minus 1 by U. We are still talking about length, so we are using length formula, and it will be 1 by F. Now it is V, okay. Now our V will be what? 1 by F plus 1 by U, and it is our V. Now if we put the values, our V will be how much? U into F, which is minus 20 into 70 by 4 upon how much? It will be F plus U, which is 70 by 4 minus 20, and its value will come exactly 140 centimeter, that too in positive. Okay, now we will calculate the magnification again. So our magnification M2 dash, I am calling it M2 dash, so it will be 140 minus how much? Upon, sorry, not minus, minus 20. So it will be like this, and it is minus 7. Okay, so it is 7. Now our M1 dash will be equal to M1, because the change in medium will not affect the image by the glass or concave mirror, we can say. So what we get here, our M1, which is equal to, let me check it, it is minus 2. So our M2, which is equal to M1 dash into M2 dash, we can say it will be plus of 14. Now our ratio of M2 is to M1, it will be 14 divided by 2. Our M1 is 2. Let me check it once again. Yeah, it is 2. So its value will be 7, and this is our answer. This question is a bit lengthy, but it's easy. I mean, its concept is easy. So our correct answer is A.
Hello everyone. A large glass slab of mu is equals to 5 by 3 of thickness 8 cm is placed over a point source of light on a plane surface. It is seen that the light emerges out of the top surface of the slab from a circular area of r centimeters. What is the value of r? So the question is asking us to find out the value of r, which is the radius of the circular area out of which the light emerges. As we can see from the diagram, the tan C is equals to R by 8. Therefore, using the Snell's law, we can write that 5 by 3 sin C is equals to 1 into sin 90. Therefore, sin C is equals to 3 by 5. And this implies that angle C is equals to 37 degrees. Therefore, from equation number 1, we can write that tan 37 degrees is equals to r by 8. And substituting the value of tan 37, we can write that 3 by 4 is equals to r by 8. And this implies that r is equals to 6. Therefore, on calculation, we can say that the value of r is equals to 6 centimeters. Thank you.
AB and CD are two slabs. The medium between slab has refractive index 2. Find the minimum angle of incidence of Q so that ray is totally reflected by both the slab. मीन्स हमारे पास दो स्लैब है, ये हमारे पास फर्स्ट स्लैब है और ये हमारे पास सेकंड स्लैब है. नाउ अगर हम दोनों स्लैब्स की बात करें तो फर्स्ट स्लैब के लिए जो एंगल होगा वो थीटा C1 क्रिटिकल एंगल होगा। वी नो अकॉर्डिंग टू क्रिटिकल एंगल डेफिनेशन की जो हमारे पास फर्स्ट एंगल की बात करूँ साइन थीटा C1 इज इक्वल टू μ1 डिवाइड बाई μ2। तो फर्स्ट यहाँ पे रिफ्रैक्टिव इंडेक्स कितना है √2 और यहाँ पे कितना है डिवाइड बाई 2, तो कितना होगा हमारे पास थीटा C1 विल बी इक्वल टू साइन इनवर्स 1 बाई √2। 1 बाई √2 किस पे होगा 1 बाई रूट हमें पता है 1 बाई √2 हमारे पास होगा 45 डिग्री पे। सो फर्स्ट क्रिटिकल एंगल मेरे पास कितना आया 45 डिग्री। तो अगर मैं सेकंड केस की बात करूँ सेकंड केस में रिफ्रैक्टिव इंडेक्स हमारे पास इस पॉइंट पे होगा। सो इस केस में जो रिफ्रैक्टिव इंडेक्स क्रिटिकल एंगल होगा कितना होगा थीटा C2। सो साइन थीटा C2 विल बी इक्वल टू मीडियम का कितना है √3 डिवाइड बाई 2। तो यहाँ से कितना आएगा थीटा C2 विल बी इक्वल टू साइन इनवर्स √3 डिवाइड बाई 2। सो √3 डिवाइड बाई 2 कितना होगा हमारे पास 60 डिग्री। सो ये हमारे पास क्रिटिकल एंगल है थीटा C2 जो कितना है 60 डिग्री। तो यहाँ से हम देख सकते हैं कि यहाँ पे हमारे पास दोनों एंगल में देखा जाए तो 60 डिग्री हमारे पास ज़्यादा है। सो इट मीन्स हमारे पास जो क्रिटिकल एंगल होना चाहिए मीन्स ये एक क्रिटिकल एंगल का मिनिमम क्रिटिकल एंगल कितना होना चाहिए 60 डिग्री। सो मिनिमम क्रिटिकल एंगल विल बी इक्वल टू मिनिमम क्रिटिकल एंगल हमारे पास क्या होना चाहिए तभी उसके अंदर से लाइट हमारे पास टोटल रिफ्लेक्शन प्लेस होगा अगर हमारे पास एंगल क्रिटिकल एंगल कितना होगा 60 डिग्री। सो मिनिमम क्रिटिकल एंगल विल बी इक्वल टू 60 डिग्री।
तो इस क्वेश्चन में एक मटेरियल है जिसका रिफ्रैक्टिव इंडेक्स √2 है और एक लाइट आती है AB पे स्ट्राइक करती है और वो रिफ्रैक्ट होती है, फिर स्फेरिकल सरफेस आता है जिसका रेडियस ऑफ कर्वेचर हमें दिया है 40 सेंटीमीटर है और फिर वो रिफ्रैक्टिव इंडेक्स 1.514 पे निकल जाती है। ठीक, तो हमें पता लगाना है कि E पे जहाँ पे वो रे मीट करती है वो डिस्टेंस क्या होगा। ठीक, तो पहले तो हम यहाँ पर देख लेते हैं एंगल ऑफ इंसिडेंस हमें दिया गया है I इज इक्वल टू 45 डिग्री है, I इज इक्वल टू 45 डिग्री। तो हम स्नेल्स लॉ लगा देते हैं, तो μ1 साइन I इज इक्वल टू μ2 साइन R। अब μ1 की वैल्यू 1 है हमें दिया गया है और साइन I की वैल्यू साइन 45 यानी कि 1 बाई √2 इज इक्वल टू μ2 की वैल्यू हमें दिया गया है √2 और साइन R यहाँ से हमारा निकल जाएगा, तो साइन R की वैल्यू जो है वो हो जाएगी हमारी 1/2 यानी कि जो R है वो हमारा हो जाएगा 30 डिग्री। ठीक, यानी कि जो R है यानी ये एंगल ये हमारा 30 डिग्री हो जाएगा और हमें पता है कि ये जो लाइन है ये 30 डिग्री है यहाँ से 90 डिग्री यानी कि कुछ ये एंगल ये हमारा 90 डिग्री है। तो ये एंगल कितना होगा कौन सा ये वाला, ये एंगल हमारा होगा 30 डिग्री यानी कि अगर ये 90 डिग्री है तो ये कितना होगा 30 डिग्री। जैसे कि इस केस में है ये हॉरिजॉन्टल लाइन है, हॉरिजॉन्टल से ये जो 90 डिग्री वाला है वो 30 डिग्री बनाएगा, तो यानी कि ये भी 30। अब ये एंगल और ये एंगल सेम है यानी ये लाइन इस लाइन का हॉरिजॉन्टल है यानी कि ये लाइन जो है पैरेलल है, तो ये लाइन हो गई पैरेलल। ठीक, अब हमें पता है कि ये लाइन पैरेलल है तो u जो हो जाएगा इस स्फेरिकल सरफेस के लिए ये हो जाएगा -इनफाइनाइट। अब हम फॉर्मूला लगा देते हैं μ2 बाई v माइनस μ1 बाई u इज इक्वल टू μ2 माइनस μ1 बाई r। अब इसमें हमारा ये टर्म 0 हो जाएगा, क्यों? क्योंकि u इन्फिनिटी है, तो ये हमारा आ जाएगा μ2 यानी कि 1.514 डिवाइड बाई v इज इक्वल टू 1.514 माइनस 1.414 होल डिवाइड बाई रेडियस ऑफ कर्वेचर हमें दिया गया है 0.4 मीटर यानी कि 40 सेंटीमीटर। तो यहां से हमारा v आ जाएगा हमारा 40 इंटू 1.514 होल डिवाइड बाई 1.514 माइनस 1.414, तो ये आ जाएगा हमारा 6.06 मीटर। ये हमारा आंसर है।